Okay, so there is the example 3 of the calculations under DC circuits. 3 resistors are connected in power as shown. Calculate I, total resistance, II, supply current, III, voltage across the power branch, IV, current in power resistor, V, voltage drop in 5 ohm resistor, and then VI, total power. Okay, so that is the circuit. Okay, and it's a series parallel circuit. Okay, all right, so let's start by numbering our resistors. Okay, so we have R1, R2, R3, and then R4. So we have 4 resistors that has been connected in series and then parallel. I hope you are following it, across a 30 volts supply. Okay, so let's move on with the solution, but please make sure you subscribe and then you share the videos. Okay, all right, thank you very much. Okay, so the first one says we should calculate for total resistance. Okay, all right, so what we are going to do is we calculate for the parallel resistance first. Okay, we calculate for the total parallel resistance first, and we have resistor R2, R3, R4 being connected in parallel. Okay, R2, R3, R4 connected in parallel and then connected in series to R1. I hope you are following it. Okay, or you can also say resistor R1 is connected in series to R2, R3, R4 in parallel. I hope you are following it. So it's a series parallel arrangement, or it's a series parallel circuit. Okay, so let's solve the parallel resistance first. Okay, so we have 1 over Rp. Rp is the parallel resistance, so 1 over Rp equals 1 over R2 plus 1 over R3 plus 1 over R4. That is the formula that we are going to use to solve for the parallel resistance. So we have 1 over Rp equals 1 over 2, that is the value for resistor R2, plus 1 over 3 plus 1 over 4. So we find the LCM, which is what? 12. So 2 goes into 12 6 times. 6 times 1 is what? 6. Plus 3 goes into 12 4 times. 4 times 1 is what? 4. Plus 4 goes into 12 3 times. 3 times 1 will give us what? 3. So we have 6 plus 4 plus 3, which is what? 13 over 12. Okay, so 1 over Rp is what? 13 over 12. So to calculate for Rp, which is the power resistance, is equal to what? 12 over 13, which is 0.9 ohms. So now that we have calculated for the power resistance, we can now calculate for our total resistance now. So the total resistance, which is what? RT, is equal to Rp plus R1. Why? Because R1 is in series to what? Rp, that is the parallel resistance. Okay, so we have 0.9 plus 5, which will give us 5.9 ohms. I hope you are following the steps. So our total resistance is 5.9 ohms. Okay, so let's move on to II, which is the supply current or the total current. Okay, so IT, which is the total current, is equal to VT over RT, that is the total voltage divided by the total resistance. And the total voltage is what? 30 divided by the total resistance, which is what? 5.9. So when you divide 30 by 5.9, we are going to get what? 5.08 amps as our total current. I hope you are following it. Okay, so let's move on to the solution III, which is the voltage across the parallel branch. Voltage across the parallel branch. Okay, so from the diagram, I1 is the current that flows through resistor R1 and is the same as the supply current. I hope you are following it. So you can say that IT is equal to I1, which is equal to 5.08 amps. I hope you understand. I1 is the same current that flows through R1 and is the same as the supply current. Okay, so we have here IT equals I1, which is equal to what? 5.08 amps. Okay, so what we do is we calculate the voltage across resistor R1, which is VR1. Okay, and we are going to use the formula I1 multiplying R1. So I1 is what? 5.08 times R1, which is 5. So when you multiply 5.08 by 5, we are going to get what? 25.4 volts. So the voltage across R1 is what? 25.4 volts. I hope you are following the steps. Okay, so let's move on. So to calculate for the voltage across the parallel branch, that is the voltage across this parallel branch, which is what? VP, we subtract the total voltage from the voltage across R1. I hope you're following it. We use the formula VT minus VR1, that is, we subtract the voltage across R1 from the supply voltage. Okay, so we have 30 minus 25.4, which will give us what? 4.6 volts. So VP, which is the voltage across the parallel branch, is what? 4.6 volts. I hope you are following it. Okay, so let's move on. All right, please take note here, because the resistors are connected in parallel. That means the voltage across each will be the same. Okay, the voltage across each resistor will be the same, because what? They are connected in parallel. Please take note of this. So we can say that VP is equal to V2, that is the voltage across resistor R2, and is the same as the voltage across resistor R3, and is the same as the voltage across resistor R4, which is what? 4.6 volts. Why? Because resistor R2, R3, R4 are connected in what? Parallel. I hope you understand. Okay, so we move on to IV. IV, which is what? Current in the parallel resistor. Current in the parallel resistor. Okay. So from the diagram we have I2, which is the current that flows through resistor R2, I3, that is the current that flows through resistor R3, and then I4, which is the current that flows through R4. And we are to calculate for what? The current in the parallel resistor, that is I2, I3, and then I4. Okay, so I2 is equal to what? V2 over R2. So V2 is what? 4.6, and then R2 is what? 2. So when you divide 4.6 by 2, we are going to get 2.3 amps. Then I3 is also equals V3 over R3, which is equal to 4.6 divided by 3. That one will also give us 1.5 amps. I hope you are following it. Then I4, which is also equal to V4 over R4. So we have 4.6 over 4, which is equal to 1.16 amps. So I2 is equal to 2.3 amps, I3 is equal to 1.5 amps, and then I4 is equal to what? 1.16 amps. Okay, so the next one, that is the V, is to calculate for voltage drop in the 5 ohm resistor. And the 5 ohm resistor is what? Resistor R1. Okay, alright, so solution V, that we have already calculated for, okay, we have already calculated for, is VR1, which is the voltage across R1, or the voltage drop in the 5 ohm resistor, okay, is equal to I1 R1, I1 multiplying R1, which is equal to 5.08 times 5, which gave us what? 25.4 volts. So the voltage drop in the 5 ohm resistor is 25.4 volts. I hope you're following it. Okay, so let's move on to the last one, which is VI, and we are to calculate for the total power. So we use the formula PT equals VT multiplying IT, that is the total voltage multiplying the total current. So the total voltage is what? 30 multiplied by the total current, which is 5.08. So when you multiply 30 by 5.08, we are going to get what? 152.4 watts. I thank you so much for watching, and please make sure you subscribe to the channel and then you share the videos. Thank you very much.